Welcome to the channel Professor Da Vinci. I am the professor. Subscribe and hit the bell icon to stay updated. Today we are going to discuss the video topic Optimizing Machine Learning, the power of gradient descent with Python code. Gradient descent is a fundamental optimization algorithm used in machine learning and various other optimization tasks. It's a key technique for finding the minimum cost or loss function, which is crucial in training machine learning models. Let's take the example cost function C omega equals omega square, where omega is a parameter to be optimized. So we need to find the gradient descent for this simple cost function. To optimize, we need to follow these steps. Step 1, find the derivative. Step 2, initialize the parameter. Step 3, set hyperparameter. Step 4, perform iteration. Step 5, monitor convergence. Step 6, visualize the process. Step 1, find the derivative of the cost function. Derivative d with respect to omega c of omega equals, so derivative of omega square power base power minus 1 and the derivative of base, which gives 2 times of omega. Initialize the parameter. So assume that we have initialized omega equal to 3. Next, we need to set the hyperparameter. So hyperparameter is represented by the alpha. So let us assume the minimum value 0.1, and we need to perform the iteration. So iteration is the omega new value equals omega old minus alpha derivative of with omega c of omega, so which gives, so omega old value is the 3 what we have assumed, so 3 minus say alpha 0.1 times of this one derivative of the cost function 2 times of omega value again 3, which gives 2.4. So this 2.4 is the result of first iteration. So perform until say 20 or 30 iterations, such a way that you need to stop in somewhere where you find the minimum difference between the old omega value and the new omega value. Now step 5, monitor convergence. So keep performing the step 4 for say 20 iteration 20 times, then we yield the omega, the cost function is 22.4, 1.92, 1.536 and so on. And if you notice at the end of the iterations, so the difference in each iteration goes decreasing. So we need to stop in a particular threshold. Either you find a minimum difference between these previous with the current value, or you can freeze with a particular iterations. So in general we can say that continue the updating omega until it converges to minimum value. You can set a stop criteria, either number of iterations to be performed or the change in omega is minimum. Step 6, visualize the process. If we plot the graph, we get the graph as shown. So there is 2 graphs. One is parameter omega versus iteration, and another cost function c of omega versus iterations. So plot the graph of C of W as a function of omega to visualize how gradient algorithm approaches the minimum of the cost function. Now the Python code. This script will create a plot with the two subplots, one showing how the parameter omega changes with the iterations and the other showing how the cost function C of omega evolves. You will see the parameter omega gradually approaching the minimum and the cost decreases over iteration. Thank you for being with me today's video. So go through this video and practice with another cost function, so you will be mastering this gradient descent algorithm. So this is the power of derivatives. See you, bye bye. Have a nice day.